Okay, good evening. Form 5. This is Form 5 Thursday group. Okay, nice to meet everyone again here online. This is your second online lesson. I think it's second online lesson, right? Okay, so hope everyone doing fine at home. Everyone doing fine at home. You study well at home, eat well, sleep well at home now. Okay, now I want to start to discuss the paper 2, your set 1, paper 2 question. I hope you have the paper in front of you now. Okay, come, I share the paper. Can see or not, everyone? Can see the screen? Tong can see or not?
Can.
Can see, okay. Everyone have this paper in front of you, okay? All right, now, okay. Go on, I do some click. I need to turn off something first, okay? Okay, we start with question number 1, okay? You look at question number 1, class. Diagram show 2 types of thermometer. You have 2 types of thermometer. This one is infrared thermometer. This one is digital thermometer, right? They are different one, This one digital. Okay, this one is infrared, but this is not the point, We want to see here. The infrared only can give 36.5, 1 decimal only. Can give only 1 decimal. But this digital one can give 2 decimal places, 37.05. I ask you all, which one is better? 1 decimal or 2 decimal places? Which one is better? Mafuza, which one better? 2 decimal or 1? Mafuza.
Yes, sir.
Which one is better? The 1 2 decimal places or only 1 decimal? Which one is better? In your opinion? Which one is better? 1 decimal better. If I say which one is more accurate, then you choose which one? You choose 1 decimal or 2 decimal?
Is 2.
If more accurate, normally we say
2.
better. Better here means refer to more accurate. Yes, correct. Your answer is correct, Mafusa. 2 decimal one. Okay, okay, now we see the question. What is a physical quantity can be measured by thermometer? Okay, thermometer measure what? Farahana. Thermometer measure what? Farahana, please answer. Thermometer can measure what?
Temperature.
Yes, temperature, correct. Measure temperature, okay? So the answer is temperature. You can measure temperature, okay? Thermometer measure temperature lah. This one okay lah, All right, next one. State the accuracy of infrared thermometer P. Now, if they ask what is the meaning of accuracy? They ask, what is the accuracy of infrared thermometer? This one. What is the accuracy? Accuracy here now. So how to give answer now? They ask, what is the accuracy? So meaning that is referring to what? What is the accuracy of this thermometer? So the words are accuracy here now. So how are you going to give the answer? What is the accuracy of this thermometer? How to give answer? Okay, Li Ka Chuan, right? Li Ka Chuan, can you come out? Li Ka Chuan, if question asks, what is the accuracy of this thermometer? How you give answer?
0.1 decimal.
Yes.
0.1.
Yes, very good. 0.1. Because you see 1 decimal. 1 decimal means the smallest is 0.1. Okay. So the accuracy here is 0.1. Because if can give 36.5, means can give 36.0, 36.1, 36.2, 36.3, meaning that the smallest division is 0.1. That's why the answer is 0.1. Okay? Accuracy 0.1, degrees Celsius. Okay, can you make a note, sir? Accuracy, you have answered 0.1. Sometimes the question can ask sensitivity. What is the sensitivity of this thermometer? You also get the same answer. Okay, both accuracy and sensitivity, right, refer to the smaller scale division. Same one, remember, please make notes. Sometimes they can ask frequent accuracy. Sometimes they ask you sensitivity. Then they are the same answer, okay? Sensitivity also 0.1. Accuracy also 0.1. Same, okay, come, next one. Based on diagram 1, which thermometer more, I just say just now, more sensitive. Which one more sensitive? Anissa, which one more sensitive? Thermometer?
B.
Which one?
B.
A.
B.
Infrared or digital?
Infrared.
Infrared more sensitive. Okay. Sensitive, you see like this now. This one 1 decimal. This one 2 decimal. 2 decimal places. So 2 decimal places mean can give more accurate answer. Can measure smaller division. So meaning that actually, in terms of sensitivity, this is more sensitive because it can measure up to 0.01. 2 decimal can measure up to 0.01. So which is more sensitive. This one can measure up to 0.1 only. 0.1, sorry, my writing very bad. Okay, this one can measure up to 0.1. This one can measure up to 0.01. So this is more sensitive. Okay, understand? Okay, please. Okay, now you see the answer. Q, the answer is Q. Q is the second one. The digital one is more sensitive. And give the reason. What reason you choose Q? What reason you want to give? Why Q is more sensitive? So one answer here. Okay, I want to hear from Emily. Emily, go. Can you come out? Emily, Emily?
Yes,
Emily,
sir.
出来一下啦。Okay.
What
reason 呢? What reason Q more sensitive?
I got 2 decimal.
Yes, correct. Yes, correct. More. The answer is can detect smaller change in temperature because it can detect up to 0.01. So which is more accurate? Okay, more sensitive. The reason is it can detect smaller change in temperature. It can detect up to 0.01. Okay. Yeah. Hey, so far I can follow now, everyone. I hope everyone focus. Must pay attention, Don't play games. Don't do other things. Okay. Okay, next. Now is question number 2. Now we study the question first. Diagram shows an insecticide sprayer. This one to spray the insecticide. Okay, how this thing work? I explain here, you all listen, So the insecticide liquid is here. You want to pump this liquid come out. So what you do is, you push the piston. Push this piston. Push to force the air. Force the air here, go out high speed. Force the air go out very fast. You force the air go out. Okay, so when the air go out very fast, got here sure fast one because narrow, very narrow, so it go out very fast. So based on Bernoulli's principle, he said, right, high speed, it become low pressure. So here now, the air move in high speed, but it become low pressure. So here become low pressure, so I write LP, low pressure, okay? High speed, low pressure. So over here, low pressure now. Then what happens is, the atmospheric pressure come in here, which is higher now. Atmospheric pressure is higher, okay? Because here is low pressure. Higher atmospheric pressure then push the liquid go up, go into the tube. Push the liquid go inside, okay? So when the liquid go up, then it get spread out. Because air come out very fast, low pressure. So higher atmospheric pressure push the liquid go up, and then it gets spread out. Okay, spread out evenly like that. Okay, spread out. Okay, this is how this thing work. Okay, name the physics principle. What physics principle? I mentioned it just now. I hope you all can hear it. Jolin, Jolin, can you come out? What
Bernoulli's
is?
principle.
Yes, correct. Bernoulli's principle. Okay, it's here. Bernoulli's principle. Okay. Bernoulli's principle. Make sure spelling is correct. Bernoulli's principle. Okay. All right. So the principle is Bernoulli's principle. Okay. Next question. Got the answer already? Okay. Next one. Next one, they ask you to take which one is correct. Which region experience low pressure? This one you already know one. Just now I said. Which region low pressure? XYZ. Which one? Chao Yang. Loy Chao Yang. Which one low pressure? XYZ. Loy Chao Yang. Can you answer? Loy Chao Yang. Which one low pressure? X here, Y here, or Z? So X, Y, Z. They ask you to choose one. Which one is low pressure? Chao Yang. Okay, he doesn't want to talk, so he typed. So he say Y. William. Chao Yang say X. William say Y. I don't know which one is correct. It should be here. Y. Okay, here is because here A move high speed, fast. So low pressure is here. So the answer is Y. Okay, Y. So William's answer is correct lah. Y. Okay. Actually supposed to put X here. It's not supposed to write Y. It's supposed to write X. Okay, like that. Okay. So the one with low pressure is Y. Okay, All right, next one. Now, then the question asks, give one reason why you choose Y. Why? What is the reason you want to give? Why the Y is low pressure? Then why? Why? Okay, come. Divish, can you answer? Divish, what is the reason of saying here is low pressure? Why? Divish?
Because they got high speed.
Yes, correct. Very good. So the answer because A move with high speed. At that area, the A move with high speed. Because the tube there is narrow, so the A go out with high speed, so it become low pressure. High speed, low pressure, remember Police principle always say one, high speed, low pressure, okay? High speed, low pressure. All right, next. Now this is 2 marks question. Explain how the instrument produce a fine spray of the liquid. I explained to you already now, okay? Now you need to explain how the instrument can spray the liquid, come out with fine spray. How? Okay, 1 minute. Try, you use your pencil, try to write your answer. I may call your name, so I want you to try to give answer, Okay, try. You look at the diagram. How this thing spread the liquid out. So you need to explain, So get ready now. Use pencil and jot down. Write down some answer. You have to force yourself to write. Okay, please start now. Yeah, try to write answer, Don't do other thing, okay? Focus. Look at the diagram. See how to write, how to explain, how the liquid go out there, spread out. Okay, come. When I call your name, you just try lah. Don't worry, okay. Don't worry about people will laugh or what. Just try. Yuan En Tan Yuan En, can you try? Tan Yuan En come out please.
Yes, sir.
Yuan En, can you try? Try to explain.
When the piston is pushed, air is
Uh-huh.
poured out through Y at a high speed.
Yes, very good. Then.
According to Bernoulli's principle, according to Bernoulli's principle,
Correct.
pressure of the moving air decreases as the speed of the air increases.
Yes, correct. Very good. Then.
The higher atmospheric pressure in the container will push the insecticide up.
Yes, correct. Very good. Higher pressure pushes the liquid go up. Then finally, what happened? I just push up only. Stop there. Yuan En got some more lagi. You're not finished, Push up, then what happened?
A fine spray liquid is produced.
Yes, correct. When we go up here, because the air blow, right? Then you can produce a fine spray lah. Okay, that's the answer. Very good, Yuan En. Okay. Now you can see the answer. Okay. The answer is here. Okay. Now, when the piston is pushed, A move out the narrow holes to region Y. Okay. Region Y has low pressure. This one is because of Bernoulli's principle lah. Then higher atmospheric pressure pushes the liquid up to the narrow tube. And finally, a fine spray is produced. Okay, so this answer. Okay, come. Jot down the answer lah. If your answer is more or less like this, so you don't need to copy lah. Okay. Okay, finish everyone. Elisa, finish or not? Elisa Tan, finish.
Yes. Yes.
Finish. Your good friend Kiritana, finish or not? Kiritana, finish.
Yes.
Finish, okay. All right, come, we move on now. Continue with the next part. Question number 3 now. Now study the question. Diagram show the water wave experience diffraction. This is diffraction. Okay. After passing through a narrow gap. Okay. So it's here lah. You see the water wave come in, right? So this is a gap. When the water wave pass through the gap, so it become curve shape already, So meaning that the water wave experiences diffraction like this. After it passed through the gap, right, the water wave spread out. So the keyword we use is spread out. It spread out, you see how it spread out to this direction and spread out to this direction. So it became spread out. So diffraction means the spreading of the wave when it passes through a narrow gap. And that's the answer, All right. But after this, you must know, during diffraction, What will not change? What will change? You all must know, you know. Okay. Okay, now we go to that later on. Okay, now first question. What is the meanings of diffraction? As I told you just now, Lord, how to write diffraction. Kirtana, can you try? I see whether you remember what I say or not. Kirtana Murti. Kirtana. How to give answer? How to explain diffraction, Kirtana? The keyword. Do you remember the keyword I say? No. Okay, come near mic. I ask somebody else. Someone must get the answer. Okay, I want to hear from Chang. Chang.
Yes.
Chang, can you explain what is the meaning of diffraction? Chang?
No.
Diffraction is don't know Hi, you I think I'm very
Tell
scared.
me.
Okay, come. I want to hear from Hui Xin. Hui Xin, can you come here? Hui Xin. Hui Xin. Hui Xin, are you there?
Yes.
Okay, Hui Xin, what is the meaning of diffraction?
Diffraction is a phenomenon in which waves spread out as they pass through an aperture.
Yes, very good. Can you read slowly one more time your answer, Hui Xin? Very good, your answer correct.
Diffraction of waves is a phenomenon in which waves spread out as they pass through an aperture.
Yes, so Hui Xin say what, you know, it's a phenomenon where the wave spread out. The wave gets spread out when it passes through an aperture. She used the word aperture. Aperture means it's a gap. Gap is a more common word, but in scientific words, we say aperture. Okay, okay, now you see the answer. Okay, now very short answer. The spreading of the wave after it passes through a small gap. A small gap, or you say an aperture also can. Aperture, A-P-E-R-T-U-R-E. Yeah, short answer will do. Spreading of the wave after it passes through a small gap. Yeah. All right, next question. What happened to the wavelength lambda after pass through the narrow gap? What happened to the wavelength lambda? What happening? You see the diagram? What happened to the lambda? You all remember or not? During diffraction, what happened to the lambda? You see the lambda here, like here. When come here. So what happened to the lambda? Elisa, what happened to the lambda? Elisa Tan? Elisa? Same, yes. You are very clever. I thought you would be cheated by the diagram. The diagram should become bigger. No, it's wrong, you know. Remains the same. Yes. Your answer is correct. Okay. Remains the same. The lambda never changes. Okay. Lambda remains the same. The wavelength remains the same. Yeah. Come back here. Come, I need to explain a little bit. You make notes, can or not? During diffraction, lambda, no changes. One more is frequency. Frequency also will not change. Excuse me. Can you jot down your lambda remains, frequency remains, and one more thing remains is the speed. The speed also never change. Very cold. I do off the aircon. Excuse me. Okay. So remember lambda never change, frequency never change, speed never change. And then what will change? Can you tell me? What will change there? There are three things never change, but some will change. So what are the things will change there? Lim Xiaohui, are you there? Lim Xiaohui? Lim Xiaohui 你出来嘛？Lim Xiaohui. 可以放讲大声一点吗？你的麦靠近你的嘴巴一点。What will change?
Yes, the direction of propagation of
Yes,
wave.
correct. The direction changes. You see direction change 嘛 Here straight, then here go here. Direction changes 咯。Beside direction, what else? 林小辉 Direction
Amplitude.
change, what else?
Amplitude.
Amplitude. How the amplitude changes then? You must know. The amplitude decreases. Make it very clear. The amplitude decreases because loss of energy. When it passed through the gap, the wave lost the energy, So no more energy already. So the amplitude decreases. The amplitude at first is very high, very high. Then after it passes through, become very big, very low already, like that. So amplitude decreases. Okay, And one more thing will change is the shape, the pattern. You see here straight line. Then here become curve. It's a shape. The pattern, the shape are also change. So remember now, three things never change, three things change. Okay. The direction changes, the amplitude decreases, and one more is the patterns of the wave, the shape of the wave. Okay, Okay, next. They ask you to draw. Can you complete this diagram, class? Okay. You see carefully here now. Over this diagram, right? The lambda small. The lambda is very small here. You see the lambda? Then the gap is very big. The aperture is very big. No, this aperture A very big. When lambda smaller than this, the diffraction is strong or not strong? Diffraction strong or not strong? You think properly, Now the gap is so big, When the gap so big, the diffraction is strong or weak. Re-end, if the gap so big like this, the diffraction is obvious or not obvious? Re-end, louder, speed.
Not obvious.
Yes, not obvious. If not obvious, so your diagram should look something like this. Okay? Now, like that. This is not obvious. Not obvious means it's not curve shape. It's straight line, but only a little bit curve like that. Curve a little bit, okay? That's all. So this diffraction is not obvious. It's weak diffraction. Okay? Copy the diagram, please. Because the gap bigger than the lambda. When the gap is too big, diffraction not obvious. So it's like that. Okay, finish, And can you jot out this diagram? When the gap is small, you see, when the gap is small, the gap become very small, like this, Then the diffraction become very obvious. It's become curve like that. 1, 2, 3, 4, like that. Okay. This one diffraction is obvious. When the gap is small, diffraction is obvious. Curve shape, This one the gap is big. Diffraction is not obvious. Not always like that. Always is like that. Please jot down. Jot down, everyone. When the gap small, it become like that. Very obvious diffraction. Okay, finish. Okay, okay, come, let's move on. And now calculation. Calculate the wavelength, find the lambda. If the velocity, this one velocity, and the frequency. So I think very straightforward formula. What formula then? You have velocity, you have frequency. How to find lambda? What formula? Julian, Julian, can you come out? What formula to use, Julian? What formula? Can use what formula?
Forward.
To find lambda, you are given velocity, given frequency. So find lambda, what formula? Liao Xing Xiang. What formula? Liao Xing Xiang.
F lambda.
Yes, correct. V equal F lambda. Okay, so use this formula, very simple. So to find lambda, use V equal to F lambda. Okay, do it now, everyone. V is 50, frequency 23. So you find lambda, that's all. Okay, very straightforward. So what answer? Xing Xiang, what answer you get?
2.1. 2.17.
2.1.
7.
Okay, come, let's see. Yes, correct. 2.17. Okay, 2.17 meter. So the lambda is 2.17 meter. Okay, All right, next. Next, question number 4. Diagram show a simple transformer. This is a transformer, you know. New one, Chiu now coming now. New. Chiu Tong, what happened to her? Chiu Tong.
Not sure.
Why so late, you ask her? Okay, come. So this is a transformer. The primary coil is here. You have 2 lines. This is a secondary coil. Okay, the input voltage is 240 AC. And then the output here, it become 5 only. It stepped down so much to 5 only. Step down already. And then you have a diode here. The diode here function is to convert the AC to DC. The function of the diode. Because transformer only can work with AC one. So AC come in, come out here also AC one, you know. But after you put a diode here, so it will change to DC, okay? Direct current. Because diode only allow current to flow in one direction. So it will change to direct current. Okay, now, what types of transformer? What types of transformer here? What types of transformer? Jocelyn? Jocelyn, what types of transformer this one?
Step down.
Yes, correct. Step down. Okay, step down transformer. Okay. Very simple, step down transformer. Okay, next one. Explain why the bulb in the secondary coil lighted up. Very good question, you know. They ask you why this bulb will light up. Why? Why it will light up? So if you only give answer because of current, then you don't get marks, you know. Okay, you have to explain how this input 240 volt, right, can step down to 5 volt, to step down to 5 volt, and then make the bulb light up. Okay, you have to explain that because you can see here that the current not coming over, no wire connecting. So how this current will produce another current here. Okay, I can tell you lah. This one is a working principle of transformer. This is one of the favorite question in the SPM. And then this Harry Young, he say, the primary coil is magnetized and linked to the secondary coil. Yes, Young, you get half of it correct. Half correct already, Young. Primary coil is magnetized and then linked to the secondary coil. Link, you must say what link to secondary coil? No, something linked to secondary coil. What is that? Okay. Think, okay, you all try to draft your answer. Use a pencil to jot. Think, okay, think of the answer. I don't want straight away give you the answer. No point when you don't learn one. You have to use your brain to think. Okay. Harry Young again. He saying primary coil magnetized and linked to the secondary coil. Then soft iron armature. Huh? No, there's no armature here. Okay. Your first part is correct, Young. Then the second part not correct. Good try. Okay. Anyone here if you don't want to talk, never mind, you can type your answer. Try lah. Let me see. Hey, Chiu Tong, don't pretend never listen to me, no. Chiu Tong.
So you call me?
Yeah lah, I call you lah then.
I never. Okay, never mind. Just now I
You
think
don't.
you like.
Chiu Tong, can you explain how this thing work and then produce a current here?
When the primary coil is coiled on the soft iron core, the soft iron core is magnetized,
yes,
and the magnetic flux is cut by the secondary coil.
Yes, correct. Because you make this thing become magnetized. So magnetized, we have magnetic flux. So the magnetic flux will cut over here, link over here. And then Chiu Tong is correct. Now what she say now? Harry Young, you are lacking of this part. No, you never say magnetic flux link over to the secondary coil. It's the magnetic flux that cut over. Okay. All right. Now you see the answer. It's very long. When current flows into the primary coil, the coil and the core are magnetized. Both of them, the primary coil and the core, the soft iron core is magnetized. Then varying magnetic flux, use the word varying now because it's AC. AC current, the current vibrating one. So the magnetic flux also vibrating one. That's why we call it varying magnetic flux. Link over to the secondary coil. So what happened? Change in magnetic flux produce. Change in magnetic flux happen in the secondary coil because the magnetic flux cut the wire, isn't it? And then change in magnetic flux produces induced current in the secondary coil, which light up the bulb. Okay. Okay, copy the answer, please. Okay. A few of you answer here. Let me check what's written. An Si Xiang, he say, secondary coil cut the magnetic flux, induced current produced enough to supply the light. Yes. An Si Xiang, your answer is correct lah. It's correct is the last part of the answer. The beginning part you never mentioned, Your answer is correct, but this one is the last part of the answer. Okay, Si Xiang? The beginning part you have to mention. Beginning part, you say when current flow into the primary coil, the coil and the core are magnetized. Okay. Okay, come. Got it already? Finish? Chiu Kai Ji, finish or not? Chiu Kai Ji.
Yes, yes.
Finish, okay. Okay, come, we move on to the next one. When the transformer is on, the bulb lighted up with normal brightness. You see, once again, they use the word normal brightness. I told you many times already, you know. Normal brightness means what? It carry a certain meaning one, you know. So what is the output voltage? Meaning that here, output voltage, no calculation required. From the word normal brightness, you should know what is the output voltage. What is the meaning of normal brightness? What is the meaning then? What is the meaning of normal brightness? Okay, this one I explain. Come. Normal brightness means the bulb light up normally when the bulb receive 5 watt, 8 watt. Meaning that when the bulb receive exactly what the bulb needed. The bulb receive require 5 watt, 8 watt. So the bulb receive what the voltage required by it. Then it will work normally. It will light up normally. Understand? When it receive the required voltage and the power. Got it or not, Jocelyn?
Yes.
Got it, when it receives the required voltage and the power, so it will light up normally. Okay, normal brightness. All right. So meaning that 5 watt no calculation required. If light up normal brightness means the voltage must be 5 watt. Okay, 5 watt. So 5 watt here is 5. Okay. No calculation. 5 watt. Okay, next one. If the number of turns of primary coils is NP, number of turns primary coil, NP, 960. Calculate the number of turns of secondary coil. So you're asked to find NS. Given NP, find NS. So what is the formula now? You remember or not? What formula? You have NP, NS, VS, VP, like that one. What is the formula? What formula leh? Okay, let's hear from Emily. Emily, can you tell me what is the formula, Emily?
NP
NP
over VP equals over VS.
Yes.
NP over VP equals to NS over VS.
Yes, can. There's so many ways you write the formula. But Emily says correct law. NP over VP equal NS over VS. Or you can write something like this. Okay, come. So you start from this formula now. Okay, you write NS over VS. Or secondary here now equal to NP over VP. Like this also can run. So many formula like. The answer here is using this formula. NS, VS, NP, VP. Okay. We are asked to find NS. So VS is, you bring this one, bring over, cross multiply, so it become here. VS bring over here, no, you get here. So NP 960, VS, the output voltage 5, the input voltage, primary coil voltage 240, so you get 20. Okay. I'm not sure the answer correct. Please check. I use a calculator to check, see whether correct or not. Check the answer, please. The answer correct not? Please check. Chiu Kai Ji, the answer correct not?
Yes.
Right, okay, come. Next one. The input alternating current replaced with the input direct current. Now we put direct current. Just now you see here, here is supposed to be AC, alternating current. Now you change this one to direct current DC. So they ask you what happened. Change to DC, direct current. AC means that the current go two direction one, go here, go here, go here, keep changing direction one, they want an AC. Now you change to DC. DC only flow one direction one direction. So what happened? Can a transformer work with DC? Can or not? Can a transformer work with DC? Jolin, can transformer work with DC one or not? Jolin? Jolin,
Cannot.
Cannot, yes. Transformer only work with AC. DC cannot one. Okay? The reason I explain now, because you need to have the cutting effect, to make the magnetic flux come here, cut, go back, cut, go back, cut, go back. So the current must keep changing direction. Understand? The change direction only cannot, so must use AC, because AC current can make the magnetic flux come, cut here, go back, cut here, go back. Keep changing direction, Understand? Must have cutting of magnetic flux here. So if you use the DC, you won't cut one. You cut one time, when you cut here, then you never go back. Because never change direction, So you only cut the first time, only then you stop already. Because the current never change direction, you won't go back. Okay? So meaning that cannot lah. You put DC, that means it wouldn't work. So the answer is no, not lighted up. The bulb not lighted up. Not lighted up, okay? Okay, come. Okay, question number 5. Okay, study the question. You study the question. Understand the question, Okay, come. 5.1 show a light travel in from A into the glass. You see now, from A going to glass. So this one refracted or bent, slightly bent up. This is refraction. Because from less than go into denser, if you bend. Okay, here, diagram 5.2 show the light travel from A into a diamond. Diamond is different, diamond, the density is much higher. So when diamond have higher density, so the light will bend more. You see, this angle become very small because bend a lot already, 21. This angle big. So this one bend a little bit, this one bend so much. So you can see here now, the higher the density here, so the refraction will become stronger, refracted more. When this is denser, diamond is denser, okay? And also something to do with the speed. You see the speed here. Speed of light in the glass is 2.0 something. This is speed of light inside the glass here. And then speed of light in the diamond is slower, 1.25 only slower. So meaning that here the light move faster. Faster, it refract less. When it moves slower, here slower, diamond because density, high density, very hard for the light to go through. So the speed slower. When it moves slower, it will bend more, it will refract more. Okay, understand? So relationship, there's a lot of things to remember here, no? Okay, now you answer the question. What is the light phenomenon here? The light bend like this. What is the name? Bending of light. What is the name, Jocelyn? The light bend like this. What is the name? Jocelyn. Jocelyn. Jukaiji. When the light bend like this, what is the phenomenon? What is the name? When the light bend like this, what is the name?
Refraction.
Yes, correct. Refraction. Okay. Refraction. Okay. The answer is refraction. Okay. So remember that, refraction. Bending of light. The light bend. Okay. All right. Next one. Compare. They ask you to compare. Compare the speed. The speed actually is already here. In the glass block, the speed is higher than this. That means here, the speed is higher than here. So you say 5.1 bigger than 5.2 the speed. Okay, but don't write, you don't write like this, class. Wait. You write in a sentence, Don't write 5.1 bigger than 5.2. Okay, wait, remember So you write speed of light in diagram 5.1 bigger than 5.2. You write that you must say speed of light in diagram 5.1 bigger than 5.2. Write in one sentence. I told you already, you never following the SPM, then it's sure gonna minus marks on, I tell you. Can, faster can, Yong. Speed of light in diagram 5.1 faster than 5.2 can, okay? Okay, next. Compare also, compare the angle R. Also very obvious when you see the angle R here, 35, here 21. That means angle diagram 5.1 bigger than 5.2 Okay, same answer Okay. But write in one sentence, don't write like this Angle R in 5.1 larger than 5.2. At least you add a few words Angle R in 5.1 larger than 5.2. Okay, the next one is refractive index N. Now 5.2 is bigger. Okay, why then? Why 5.2 become bigger now? Refractive index. Okay, come, let me explain. Diamond density is higher density. When the density is higher, right, the refractive index also become bigger. Same one. Denser medium, the refractive index become higher. This one less than, refractive index is smaller. That's why the refractive index here, 5.2, bigger than 5.1. Okay, what is the meaning of refractive index? Okay, it's meaning this. When it can refract the light more, this one bend the light more, isn't it? So refractive index bigger. Okay, reflect the light more. This one refract the light, bend the light less. So the refractive index is smaller. Another meaning means refractive index means the ability to bend the light. When the ability to bend light bigger, refractive index is bigger lah. That's why 5.2 bigger than 5.1 Understand I talk a lot already or you understand or not? Okay. The best is I ask you all to repeat. Kirtana. Kirtana, can you come out please?
Yes, sir.
Can you repeat what I said? Just I say a lot of things. Or can you recall what I said, Kirtana?
The reactivity index is the ability to bend the light.
So how leh?
How?
The higher the density, when the density is higher, then what happens?
The higher the bigger the refractive index.
Yes, correct. Okay, thank you, Kiritana. Okay. Yeah. Focus on, you must say focus, you know. Okay, next one. Refractive index is settled already. Okay. C. State the relationship between the speed of light and the angle R. Now you go and write the answer. What is the relationship between the speed and the angle R? You see the diagram, you know already lah. No? Here faster, isn't it? Higher speed. Here higher speed, here lower speed. When the speed is higher, the angle R bigger. When the speed is slower, the angle R smaller. So what is the relationship? What answer it? Jocelyn? Jocelyn, what is the relationship between the speed and the angle R? Jocelyn? Jocelyn disappeared already. Most probably, I think she went to toilet. Jocelyn 是吗？上厕所是吗？慧心 can you come out? 慧心
Yes, sir.
慧心 can you give the answer? What is the relation between the speed of light V and the angle R? Slowly, talk slowly, 慧心 慧心
The higher the speed, the larger the angle.
Yes, very good. One more time, can or not? Say one more time.
The higher the speed of light, the larger the angle R.
Yes. Okay. Thank you very much, Wisin. That's the answer. Okay. The higher the speed of light, the larger the angle R. Okay. The higher the speed of light, the larger the angle. Refraction, the spelling is wrong. Please, wait. See carefully. Refract, F-R-A-C. The higher the speed of light, the larger the angle refraction R. Okay, this one done. Okay, next one. My nose problem. Very hard to talk now. Cannot breathe. Okay, come, next one. State the relationship between the refractive index and the speed. Now you see, what is the relationship between the refractive index and the speed? You see the diagram? Okay. This one, just how we say refractive index diamond is higher, but the diamond moves slower. The light moves slower. And then here, the glass, we say refractive index is smaller, but the light travel faster. Then what is the relationship like that? What answer? Pelton. Okay, right, Pelton? Pelton,
Yes,
come
sir.
out, please. Pelton, what answer here?
The bigger
Relationship. Put your mic nearer to your mouth.
the bigger the refractive index,
The bigger the refractive index.
the slower the speed of light.
Yes, correct. Very good. The bigger the refractive index, the lower the speed of light. Okay, the higher the refractive index, the smaller the speed of light. Okay, that's the answer. Okay, come next. Diagram 5.3 show a situation where Ahmad can see the image of fish in the water. Ahmad can see the fish inside the water. New one, Chu. What happened to her? Qiu Tong, what happened to your good friend?
I don't know. She never replied me.
I saw her in now, only don't know what happened. Okay, so first is there here. You see, the man trying to shoot, shoot the fish. But actually, this is not the fish, this is only the image of the fish. The actual fish actually is somewhere here. You know why? The actual fish actually is here, This one is a real one. This one is a fake one. This is an image only, image. So you shoot like that, no, you cannot get one. You have to shoot lower. You know why? Because you draw a normal line here. When the line from the actual fish go, the light travel here. So what happened to the line? It will bend, isn't it? Bend. It will bend one, no. The light got refracted, it will bend, bend away from the normal, tensor to less 10. So bend away from the normal. But the man see in a straight line. So most probably he will see the fish here. Okay, like that. When he see in a straight line, so the fish is here. So, but this is not this is a fake one, this is an image. So he shouldn't point the arrow here. He have to point here. Understand? But you understand what I say or not? You don't understand or not?
Understand?
Hui Xin understand?
Yes, sir.
William Cheng understand or not? William Chen This William Chen disappeared already Harry Young understand?
Okay.
Okay, William Chen say yes. Okay, okay, good. William, at least you are there. William, why you don't want to talk? You want to type, you don't want to talk. Okay, now let's see the question. On the diagram, draw two lines, ray 2. They ask you to draw 2 to determine the actual position. 2, So this one is not enough. This one only. So let's see the answer. Like that, same lah. Some more the arrow is wrong. It should be like that. Yeah, like that. Like go up, then see. Okay, draw this diagram. The line should go into the eyes. Okay, so the arrow should go up. So when the man see in straight line, so you see the fish here. Yeah, draw the diagram. Okay, finish. The next part of the question. Oh, that's all. One question only like that. Okay, now come next one. This one is multi-cross tube question. Okay, look at the diagram. Diagram 6.1, 6.2. There are two diagrams, this 6.1, this 6.2. Let's see the diagram first. What is the difference? What is the difference? Okay, now one you see here 3,000 watt, but here 5,000 watt. Mean here the wattage is higher. Okay, here 6, here also 6, same lah. So what you see here now, when the wattage is low, 3,000 only, right? So you see now the cathode ray only deflected a little bit only, deflected less. When the wattage is higher, right, it will deflect more. See, deflected more, bend more lah. Of course, the force is stronger lah. So over here now you have electric field. Electric field, because you connect to the high power high power connect to here, so you have positive. This one is positive, so here is positive. Okay, positive because connected to positive. Then this one is electron. Electron will be attracted to the positive. That's why it bend down. Okay, this one bend more because this voltage is higher, so the electric field is stronger lah. That's all lah. Stronger electric field, so it will pull it down stronger. That's all. Okay, I think that's all lah. This question, right? Now the question. What is a process of emitting electron? What is the name of the process releasing the electron? When you on this filament hot, heat up the cathode, cathode release the electron, correct not? So the process of releasing the electron, what is the name? What is the name of the process? What is the name? Okay, come. Must call people to answer. I cannot every time I give answer. Okay, can someone answer there already? Let's see. William Chen say lazy. William Chen say thermionic emission. Yes, correct. William, you are right. Thermionic emission. Okay. Thermionic emission. Thermionic emission. The answer is when the heated cathode release the electron. So you say thermionic emission. Okay. The release of electron from the heated metal surface, that is called thermionic emission. I want to test you on one question. I see how smart you are. Okay, come. Chuang, okay, Chuang Chuang, come. Chuang 来. Chuang 有在吗? Chuang.
Yes, sir.
Chuang. Just now I said thermionic emission is a release of electron from the heated metal surface, isn't it?
Yes.
What is the best metal can release the electron one?
Tungsten.
Yes. Chuang, you are very good. Okay, number one, you very good. Chuang. Tungsten. Tungsten is the best. Okay, tungsten can release very fast, release the electron. Tungsten, now remember, Okay, next one. State one reason why extra high tension voltage is used. Why here we use EHT, extra high tension voltage? Why we need to use this one? For what? Okay. The reason now you see why you need to have extra high tension, right? It's like this. This voltage only heat up the filament. The filament become hot. So it will heat up the cathode. Cathode only release the electron. The electron won't fly one, The electron will stay here until you turn on the high voltage. So this high voltage, because the voltage is too high, it will push the electron to fly. Understand? That's why you need to have the high voltage. The high voltage is the one who accelerate the electron. Okay, someone give the answer. Let's see what is. Harry Yong saying high voltage supply. People ask you why you high voltage supply, then you answer high voltage supply. Now, Yong, why? They ask you why must you high voltage supply ma? Why? So what is the answer? Huh? Yuan En na? What answer na? Why need to use a high voltage? Tan Yuan En? Not there already. Okay, come. Chan Yen Wu. Someone answer. Let's see what Tan Yuan En type only. She cannot talk now. Type only. To accelerate the electron. Yes, correct. Yuan En, you are correct. To accelerate the electron. Okay. So the answer is to produce high potential difference to accelerate the electron. Okay, this answer. To produce high potential difference to accelerate the electron. Yeah, okay, move on. Next question, compare. You see, the pattern of the question are sure compare one. No? Compare the magnitude of potential difference, you already know lah. This one 5,000, this one 3,000, so this one lower than this lah. Okay, write the answer lah. Answer is here lah, just show you lah. 6.2 bigger than 6.1. 6.2 is 5,000. This one 3,000. This one bigger than this. Okay, angle of deflection also the same law. 6.2 angle bigger than 6.1. Please write in sentence. Don't write like this. Okay, don't follow what I wrote here lah. Okay, write in a sentence, please. Yeah. Okay, come next. Chua ask how to write in sentence, or Chua ask no. Okay, how to write in sentence. Okay, the answer is like this, Chua. For example, like this lah, magnitude of potential difference, right? So you write magnitude of potential difference in diagram 6.2 higher than 6.1. That's right in sentence. Magnitude of potential difference higher in diagram 6.2 higher than 6.1. Got it or not, Chua? And for this, you write angle of deflection. The spelling also not correct. Angle of deflection of shadow and the green line is bigger in diagram 6.2. Like this lah. The angle of deflection of shadow and green line in diagram 6.2 bigger than 6.1. You write in sentence like that, Chua, understand?
Okay.
Okay. Yeah, okay, good. The next one. These are all done already. Now C. Based on answer 6B, state the relationship between the magnitude of potential difference with the angle of deflection. I think very straightforward. Someone already answer. Sung Ho-man give the answer. Sung Ho-man say, no, not answer. He ask question. This Sung Ho-man always slow one. Always people go other question, then you only go backward. Sung Ho-man. Is that the function of anode to focus the ion to flow in one direction? That one is focusing anode. No, it's focusing anode. Song, understand or not? There are two anodes. One is focusing anode. one is accelerating anode. So the one focusing anode is to focus the electron move in one straight line. And that's correct. So understand? Okay, now, Songa, can you answer this? What is the relation between the potential difference and the angle of deflection? Song Homan, can you answer? Che Fu Hao, can you answer? Che Fu Hao? Che Fu Hao,
I write directly.
What is the answer?
I write directly proportional.
No. No graph given. Don't write this answer unless you see a graph, a straight line.
Oh,
No graph.
Cannot
So
write
you
like this.
cannot write directly proportional.
Oh,
Can you give other answer?
yes. The higher
higher,
the potential difference of EHT, then the bigger the angle of deflection.
yes, correct. That's a correct answer. Che, understand?
Okay.
The higher the potential difference, the bigger the angle of deflection. This one same direction. Sorry, just now you were discuss. Both go to the same direction. The higher the potential difference, the bigger the angle of deflection. Okay, just now this one, wait, please jot out this answer. Direction of deflection of shadow and green light same lah. Both go to the same direction. Both go down. Okay, come next. Now put a magnet. Diagram show two magnets with the opposite pole. Here is north, here is south. Now the question. On the diagram, draw arrow to show the direction of deflection. Okay. Can you use your hand? Use your hand to find the direction where this shadow will move. Use what hand? Chuang, use what hand, Chuang?
Fleming's left hand rule.
Yes, correct. Fleming's left hand rule. Your left hand like this. Left hand, 3 fingers. First finger show the direction of magnet, north to south. Second finger show directions of current. And last, your thumb show the direction of the force. The force is the one who push the thing move lah. Understand? So I say it again. First finger is a magnet north to south. Second finger is current. Third is a force. So you see where is your thumb. Okay, can you? Your first finger follow here, north to south. Okay, please. First finger point from north to south. Your first finger please point from north to south. And your second finger point here. Why the current go here? Because electron move here, current move terbalik. Electron are flying over Electron fly here, so current terbalik lah. We know that current and electrons are always terbalik lah. Electron fly here, current. So your first finger here, second finger here. Then your thumb go up. Yeah, yeah. So meaning the answer is here. You see, your first finger show here. Second finger, the current go there. So your thumb will point up. You have to practice, I cannot show you here because you cannot see. Okay. So practice. Use your left hand. Left hand. Flaming slow. First finger follow the magnet. Second finger follow current. So you turn your hand now. Then finally you will see your thumb point up to the sky. Okay. Then the answer is here. The arrow go up. So meaning that this shadow will go up. The shadow will go up. Yeah. Yeah. Next question. State the physics rule. Just now, Chuang mentioned already. Fleming's left hand rule. Okay. Fleming's left hand rule. Fleming's left hand rule. Your left hand like this Fleming's left hand rule. Okay. Okay. Just revise a little bit lah. Fleming's left hand and Fleming's right hand got two, isn't it? Do you remember or not? Left hand is for what? Right hand is for what? Fleming's left hand rule for what? Fleming's right hand rule for what? Chefu how?
Left hand is motion of the.
Yes, correct, correct. Left hand is to find the motion, find the direction of force. Your right hand, Fleming right hand is for what?
Find induced current.
Yes, correct. Very good. Che, you are very good. Okay, you can remember.
Thank you.
Sure, you get A+1. Che, you believe what I say?
Huh? Yeah, okay.
I
Yes.
say sure you get A+.
I know. Thank you.
Just need to be careful. I'm sure you get A+. Okay.
Yeah.
So right hand Fleming right hand is to find the directions of induced current. So remember right hand is to find direction of induced current. Left hand find the direction of force. Okay. Now next. Number 7. Okay, study the question. Study, okay, study a little bit. Okay. Diagram 7.1 show the arrangement used to investigate relationship between the pressure and temperature. So pressure and temperature mean this is pressure law. Correct not? P and T pressure law. So you remember this formula or not? P1 over T1. Pressure 1 over temperature 1 equal P2. Pressure 2 over temperature 2. The formula very important. This one pressure law formula. P1 over T1, P2 over T2. So but make sure the temperature T1, T2 you must change to Kelvin. You will use this formula. I remind you many times already. The temperature must be in Kelvin. William Cheng, why so fierce? Okay, come. Now you see the question. You have this stove. Stove means heat up the water. When you heat up the water, right, so the temperature of the gas become higher. When the temperature is getting higher, the pressure, you push, you can see the pressure get higher. Common sense when pressure is higher, the temperature is higher, it's hot, right? If hot, definitely the pressure here become higher. Okay? So it's related one. The higher the temperature here, the higher the pressure here. The reason later on they will ask you. I don't want to tell you first. Huh? Okay, now question. Name the gas law. I say already, no? What gas law? Harry Young, what gas law?
Pressure law.
Yes.
Pressure.
Yes, pressure law. Pressure law, huh? Okay, all right, next. Based on the experiment, sketch a graph of pressure P against the temperature T. You sketch a graph, pressure against the absolute temperature. Absolute temperature means must be in Kelvin. Temperature is in Kelvin. Okay? So your graph look like this. Now, okay? Temperature is in Kelvin, so you start from 0. Start from 0, directly proportional. The higher the temperature, the higher the pressure, directly proportional. Okay? But make sure this temperature is in Kelvin. No? In Kelvin only, you start from 0, 1, If not Kelvin, you won't start from 0, 1. Okay, for example, like this. Jot out this. If the temperature here is degree Celsius, not Kelvin, degree Celsius, here is pressure. So the graph become like that. It doesn't start from 0, 1. Remember or not? Then when you extend the graph, you find a very important number here. What is this number? You remember or not? When it's degree Celsius, your graph is like that. When in Kelvin, like that. Then what is very important? What number is here? When you extend the line, what is the number here? What is the number there? Q. Q, what is the number? Yes, negative 23273. Your name is correct. Negative 273. Jot out this graph, Celsius start from here. Kelvin start from here. And then when you extend, you get negative 273. Chua. Is it absolute temperature, not absolute 0? Chua. Absolute temperature refer to Kelvin scale. If absolute temperature means the temperature is in Kelvin. Okay? Absolute 0 is different, Absolute 0 means 0 Kelvin. 0 degree, 0 Kelvin is absolute 0, or negative 273. Negative 273 same as 0 Kelvin. So negative 273 is called absolute 0. Understand? Absolute 0. Okay, please make sure here. This temperature is called absolute 0. Okay, same as 0 Kelvin, absolute 0. Okay, sure, understand?
Okay.
Yeah.
Okay.
Okay, this one finished, everyone. Okay, next. State the temperature of gas in degrees Celsius. Okay, this one done already, 237. Okay, negative. Okay, negative 237. 273, sorry. And please make a note here. This one is absolute 0 temperature, absolute 0. Okay, right here, absolute 0. Absolute 0, not absolute temperature. Wait, different one, Absolute temperature refer to Kelvin only. Okay, when this one negative 273, this number refer to absolute 0 degree. Okay, absolute 0. Okay, next, last calculation. Can you do? Pressure of gas 3.2, temperature 2. Calculate the pressure when the temperature increase to 32. Okay. So you can use a P1, T1, P2, T2 the formula lah. Okay, like this Okay, now P1 over T1, P2 over T2. But make sure that both temperature must change to Kelvin. This one change to Kelvin. How to change to Kelvin? Chiu Tong, how to change to Kelvin?
Plus 273.
Yes, correct. 2, you take 2, 2 plus 273, so you get 275. 32 plus 273, you get 305. Okay, so you calculate, you get this answer. Hanis, understand or not? Hanis, this one is not 105. This is what? Anissa.
Yes.
Hanis, can you tell me, this not 105. This one should be what, Hanis?
10 power of 5.
Yes, correct. This is 10 power 5. Not 105, 10 power 5. Okay? Like that. 10 power 5. All right, I think okay lah. Everyone got the answer already, Okay, next. Next one. This one is that they ask you to give suggestion one, Diagram show a pot that can function as pressure cooker. A pressure cooker. So this pressure cooker, you have cover of the pot. This is a cover. Safety valve. Valve means to release the pressure one. Inside the pressure is very high. Release the pressure. Main valve. Got 2 valve, Main valve also release the pressure. And then here, the body here is thin aluminum wall. I say cannot. This one no good. Thin aluminum sure out one. Thin not good, because the pressure inside is very high. So you must use a thick aluminum wall to withstand the high pressure. So cannot use thin aluminum wall. Okay? Okay, that's my opinion now. Okay, now we see the question. Using kinetic theory of gas, explain why the pressure in the cooker increase when the temperature increase. Now they ask you, why when you heat it up, the pressure inside become higher? Using the molecule to explain, kinetic theory refer to the molecule, how the molecule move. Why when the temperature is high, why the pressure become higher? Think, everyone 1 minute, later I call your name, don't run away, I know some of you chabut already. No self-discipline, cannot. You must have self-discipline, Why when the temperature getting higher, the pressure become higher? Okay, come, I want to hear from Liao Xingxiang. Okay, Liao Xingxiang, can you try or not? Xingxiang?
Um,
Why? Why when the temperature high, the pressure become higher? Why?
when the temperature increase,
When the temperature increases,
the kinetic energy of the Q increases.
yes, the kinetic energy of molecule increases lah. So what happened?
The collision between the
the
wall of the
more,
pot and the air molecule increases.
yes, very good answer, correct. Thank you, Liao Xingxiang. So what Xingxiang say was this, he say, when temperature getting higher, the air molecule receive more kinetic energy. More kinetic energy show that the gas molecule will move faster lah. When it move faster means it will collide the wall of the container. The pressure come from the collision molecule collide the wall, you know. When you hit the wall, only got pressure one. So the frequency of collisions of molecule with the wall of the container, right, become higher. So more often it collide the wall. So this will make the pressure higher. Okay, can you write the answer? Okay, come let me show you the answer. Okay. When the temperature increases, gas molecule gain more kinetic energy. Frequency of collision with the wall of the container increases. Then higher pressure is produced. Yeah. Copy the answer now. Okay, finish. Everyone, finish. Okay, next one. Suggest a modification to the board that enable it to function safely. I told you already just now. Which part cannot be used? Which part must be modified? Farah, are you still here? Farahana. Farah, senyap tidak Farah Nita. Dia kata yes. Farah, can you tell me which part must be modified? Which part must be modified? Can talk or not? Talk faster lah. Which part must be modified? You see the diagram? Which part cannot be used? Yes, aluminum wall. Yes, correct. Aluminum wall have to be modified. Okay, so what you write here? You write use thicker aluminum wall. Use thick aluminum wall lah. Don't use a thin one. Use thick aluminum wall. Use thick aluminum wall, and the reason is what? Why use thick aluminum wall? Harry Young. Harry?
Yes.
Why use thick aluminum wall? Why here must be thick aluminum wall? Why?
to overcome the
To overcome
larger pressure.
Something like that lah. To withstand, to tahan the pressure. Okay.
Tahan, okay.
Hey, you write to tahan pressure in SPM also correct, you know. Can campur one. Can campur one.
But the coccyri say cannot oh. They say very dangerous ah. Okay lah.
Campur one. Campur.
如果我错了，我讲你教啦。
Bilingual what? The paper is bilingual paper what?
Okay.
It is stronger and can withstand higher pressure. When it is thicker lah, it is stronger and can withstand higher pressure. Yeah, is that okay lah? Next one. This one. Electric one. Diagram show an incandescent lamp. This is a lamp lah. The lamp uses tungsten as a filament. This one tungsten. Tungsten is good in releasing the light. Okay, it will release the light. Tungsten. Okay. What energy changes occur in the bulb? In the bulb, what energy change to what energy change to what energy then? Hanis, can you answer? Hanis, Hanis, in the bulb, what energy change to what energy? Hanis?
Yes, sir.
What energy change here? What energy change to what energy?
Chemical energy to
Electrical energy to?
light.
Light?
Plus,
light and?
heat.
Yes, correct. Light and heat. The answer is here. Electrical energy to light and heat energy. Got two light and heat together one. Sung Horman, to withstand pressure, he always slow. Sung Horman, Man Pan Pai, with now only he keep the answer to withstand pressure. Yes, correct lah. Sung Horman, your answer is correct. Yeah. Now P. The power of the lamp, 20 watt, is 20 watt. Resistance of tungsten is 120 ohm, very high resistance. This one must be high resistance one, you know. High resistance means it become hot, become red color to produce a light. And it's used for 2 hours, long hours, you know. So you have power, you have resistance, you have time. Okay, now calculate the current flow. To find current, what formula? You have power, resistance, time. How to find current? What formula now? P equal what? VI cannot because no voltage given. So you can only use I square R. Okay, use this formula. Okay, to find the I. Power 20. Resistance 120. You find the I. Okay.
Sir.
Yes.
如果找 power loss 用什么 formula
I square R 咯。
一样OK。
Yes. Power loss is I square R. Energy loss is I square RT. Yeah. Okay, next one is to find electrical energy. Okay, to find energy, so you take I square RT lah. Power multiply time. Power is I square R. So it become I square RT. Okay, now. Yeah, finish or not? Yeah, come. Next, move on. Next one, they ask you to choose. Tables show the comparison between the lamp, compact fluorescent lamp, and the LED. These three bulbs give up the same amount of light. Okay, see now. This one, 75 watt. This one, 20 watt. This one, 12 watt. This is the best. Because it say, give up the same amount of light. Brightness same, brightness same. But this one, the power very small. That means it save a lot of energy. Use less electric. Understand? Yeah. So you ask me to choose, definitely I choose this one already. LED is the best. In fact, now most of the house now we change the lamp. We don't use this fluorescent light already. We use LED. LED, the light you can very easy to recognize when you press a button. You press a button, it light up very fast one. That is LED. Okay. Before this, before LED, right, we have fluorescent lamp, fluorescent light. Fluorescent means you on, you have to wait 1-2 seconds, then we light up. The one is fluorescent. Okay. Bulb is different now. Bulb this color, the light color, yellow color one is bulb. This one is like daylight. This one like daylight now. Okay. Now lifespan, this one the best law, you see. So long, you can tahan so long, can save a lot of money. Okay. Producing heat energy. Heat energy no good, we don't want heat energy. This one least. Least energy produced means that it won't get so hot. No energy loss. So it's good one, right? No loss of energy. So I think that, this is the best already. Okay. Now can you answer the question? You already know the best is here. You choose, you go and write the answer, keep the reason. Power, choose what? Reason what? Lifespan, choose which one? Reason, choose which one? Producing heat. Okay. Listen, you don't write the number here, For example, like power of lamp, right? You don't choose 12 watt. You say, what suppose you say that? Xing xiang? Xing xiang. Power of the lamp, how you write?
Low power.
Use low power. Don't use a number, understand? Low power. Okay? Low power. Reason is what? Eddie Young. Why choose low power? Eddie Young. Why choose low power? Wei Xian. Why we choose low power? Wei Xian. Wei Xian.
Save the power.
Save what? Choose low power. Reason is what? Okay, let's see. Save energy. Yes, correct. Song Horman, correct. Save energy. You can save energy by use low power, save energy. You can pay less. Correct not? Save energy. Yeah. And lifespan same. Don't choose and don't write 1,000, 8,000, 25,000. So how you write lifespan? Lifespan, how you write? Yuan En?
Long lifespan.
Long lifespan, right? Long lifespan, okay? Reason, what is the reason why you choose long lifespan? Re-end, what reason? Re-end? Re-end,
Yeah, sir. Can be used longer.
Yes, correct. Can be used longer, last longer. It lasts longer, and then you can say it save cost, save money, correct? Not you do need to replace, And the last one, producing heat energy. What do you say there? Producing heat energy. More, less, least. So which one to choose? Very common now. Wen Kang, Chan Wen Kang. Come on, Chan Wen Kang. Chan Wen Kang, can you come out, please? Wen Kang, or the one to talk one. Low, yes. Low, You see carefully the table got low or not? Wen Kang, producing of heat energy, you choose low or you choose least. This is not a number. If not a number, mean you can use one, can use a word. Choose a list Yes, correct. Wen Kang, list. Choose a list Reason is what? Why choose a list? What is the reason you want to give? What reason you want to give? Why choose low? Why choose a list? Reduce energy loss in the form of heat. Yeah, this answer very good. Reduce energy loss in the form of heat. Okay, You can check all your answer Low power, save energy, save cost. Long lifespan, lasts longer, does not require to replace oftenly. Produce less heat or least reduce energy loss. Okay. And last, you choose which one you want. And Yuan say, can I write to increase efficiency? For which one, Yuan? Which one? Which answer? The last one, Yuan? Is it the last one? Yeah, last one. Yes, last one can. Yuan? It's the same meaning because can reduce the energy loss. When you reduce the energy loss means you make it more efficient, right? It's more efficient. So your answer is correct, Yuan. You can say increase the efficiency. Can. Okay, so the last one, you make your choice. So the one you choose LED. Okay, that's all, LED. Yeah. Okay, I think we stop here for tonight. Okay. For the other question, like the offset one, right? The objective question, you all do first, Paper 3, you all can do first, Don't wait for me already. Do first. Okay. So anyone want to ask any question here? Chiu Tong, any question or not?
No.
No question. Lim Xiaohui, any question to ask here?
No.
No question. Chua, any question?
No.
No. Elisa Tan, Kirtana, any question? No. Okay. If no question, remember continue to work hard. Every day I say the same thing because I really want you all to work hard at home, Now you all stay home, right? So stay home, your self-discipline become very, very important. You must have the self-discipline. Wake you up early in the morning. You have to stay strong to make yourself wake up early. Understand? Self-discipline is very important, Okay? Only your self-discipline can guarantee your success in your future, in your SPM. Understand? So please remember to work hard. Okay, study hard, and of course, take good care of yourself. Okay. So I see you again next week. Okay. Bye bye. Bye bye, everyone.
Thank you.
Sir.
Yeah.
Thank you,
Okay. Bye
sir.
bye. Bye bye. Bye bye.
Thank you, sir.
Bye.
Bye bye.
Thank you, sir.
Okay. Bye bye.
Thank you, sir.
Okay. Bye bye. Bye bye. Okay. Bye. Study hard, everyone. Study hard.
Thank you, sir.
Okay. Bye bye.
Bye bye.
Okay.
Bye
Bye
bye.
bye. Young, you very funny, you.